In this video, we will continue on the beginner's guide to SDL2 in 4th, specifically the G4th language. This is the 6th video, so if you're just starting out with this video, you'll want to go to github.com Programming Rainbow Beginner's Guide to SDL2 in G4th. You want to clone that repository. Like I said, if you are just starting out with this video, you can take the source code that we left off in the 5th video. That was the last video. You can copy the main FS and copy it into the top level directory, and then you will be where we left off in the last video. So let me show you where we left off in the last video. So we have the 800 by 600 window open. We have a image loaded and displayed as the background, and we also have a true type font loaded into a surface and a texture called SDL, and it's moving around the screen and actually bouncing off the edges of the screen. We also have the title is not correct. It should say moving text, so we'll fix that. And we have an icon that is loaded, and I showed it to you a couple videos back. So before we move on, let's go ahead and fix that. Right here in the constants, right here. This should be moving text. So we'll save that. And right up there, it says moving text. Perfect. So what we're going to do in this video is we're actually going to load a player sprite. So we're going to load another image like we did with the background image, but this one is not going to take up the whole screen. We're going to have a rectangle for that, and we're going to be able to move it around, but we are going to do it a different way. We're not going to be checking key press events. We're going to be checking key states instead. So a bunch of stuff that we've already done before, we're going to use it again in a slightly different way, but then we're going to add a little bit to it. So our new function or word that we're going to be working with is called SDL query texture, and we're not going to need it just yet. So let's just go back to the code and start working on what we need. So in the images folder, let me close that folder. So up here in images, we have the background image that we're loading for the background. And we also have this other G4th logo that we loaded in a prior video just as a surface. And we loaded it so that we could use it to set the window icon. Now we are going to use this same image to make our player sprite. Okay. So what I want to do is I'm going to go down here to, we're going to need to hold the player sprite image. And I'll just call that sprite image. So down here, and we know right away we're going to need a couple things. We're going to need to hold the sprite image. We're also going to need a rectangle, and I also want a velocity. So right up here where the constants are, I'm going to make another one, and we're going to let the player sprite move faster than the text moves. So we're going to set this to 5. So constant, and I'll call this sprite vel. Okay. Now down here, I do need the image that will be for the player sprite. So we'll put null value, and we'll call it sprite image. But we also need a rectangle for this. So I'm going to create a rectangle just like I did above with the text rect. We'll make one for the sprite. So create sprite rect. And this will be an SDL rect, and we'll allot it. Oops. Yeah, I put a 0 there instead of an O. Okay, so that should be good enough right now. That will let us load we don't actually need this constant just yet, but we know we're going to need it later. But we have something to hold the sprite image, and we have a rectangle. So if we go down to load media, we're going to do the exact same thing that we did to load the background. So I'm just going to yank that whole block of code there. The reason why I'm saying yank is because in NeoVim, you press the Y key for yank to like copy something. If you're wondering why I keep saying that. Okay, so Yeah, so we do need the render, and the image that we're going to load is called G4th logo, right there. And we are storing it in Sprite image. So we need to check it down here in Sprite image. Okay, so that lets us load the image, and since we've loaded the image, we need to unload the image. So we're going to go up here to Game Cleanup, and I'm just going to take this right here. I'm going to yank that because it's going to be the same thing. I just need to change the names, and this will be Sprite image, and this one will also be Sprite image. Okay, so let's just see if our image is loading correctly. And I haven't dealt with the rectangle yet. That's fine. We're going to come back to that. But first, I'm just going to display it. And I'm going to do it exactly the way I displayed the background. Okay, so I'm putting it here. And let me just talk about the way that stuff gets drawn is it goes from the top down, it's going backwards to front. So imagine if you're painting onto a canvas, the first thing that we painted is the background image. Then we paint the text image on top of that. So it's closer to us and it's on top. And now the next thing that we're going to paint, the sprite image, is going to be on top of that. Okay, so it's back to front. So the first thing is in the back, the next thing is on top of that, and on top of that, and then. So what we should get here is we should get the logo stretched. It's not actually a very big picture, so it's going to look really ugly because it's going to be stretched because I'm using null for the source rectangle and null for the destination rectangle. So we're just going to make sure that the image is loading first. Okay, and there's that really ugly image. That's because, again, we're stretching it. So what we need is we need to populate a rectangle. And the way that we populated the rectangle earlier was by getting the width and the height out of the source, or out of this surface, sorry. But we've loaded this image directly to a texture. We have no surface to get that width and height out of. And that brings us to our first word of the day. So this one is called SDL query texture. And what this does, it can do several things. It can give us different information about the texture, but two of the things that we can get is the width and the height. So this SDL texture, it takes in the first argument, or the first thing that would need to be on the stack would be the pointer to the image. And then the next thing is the format. And we don't actually need any information about the format. So if we leave this null, basically this is a C function and we're passing in pointers, and this function is going to populate those things, those pointers that we passed in. So we don't need anything to populate, so we're going to pass in null. And the same for access. We don't need any information about that, so we can just pass in null to that as well. So we have our image pointer, then we have null, and now if we pass in a pointer to where we want to populate our width, it will populate it for us. And luckily enough, the rectangle is already a pointer, so we just need to pass in the offset to the rectangle for the width and for the height. Now the rectangle is already a pointer, and to get to the width part of the rectangle is just an adjustment of that pointer, so we can do that just fine. So let's do that. So I'm going to do it in the same load media section. So right under where we loaded it, I'm now going to use the SDL query texture to try to populate the width and the height. Okay, so we just have to think about what needs to be on the stack first. So the very first thing that needs to be on the stack is just the address of the image. So that is just going to be sprite image. Okay, so that's the address to the image, the SDL texture. Now the next two items are both null because that's the format and the access, and we actually don't need those at all. So we can just put null. Now null is not a keyword in Forth, but it is defined up here as a constant, which is just 0. So you could use 0 as well. Right there. So That's our image. That is our format and access. And now we get to the width. So the way that we're going to get the width is we're going to do the sprite rect. And we can, I'm not going to make it complicated. I'm just going to get the offset. We can do this, and then we can just do it again. Sprite rect and SDL. And this one will be height. Okay, so I was trying to think of maybe there's a way I can copy the address over, but it's just simple enough just to put it twice. So on the stack, we have our address, we have 0, 0, we have the address to the W, and we have now the address to the H part of the rect. Okay, so the next thing we're going to do is going to use the SDL query texture word. Okay, now this is going to return this is going to let us know if this failed or not. So it returns 0 on success or a negative on failure. So we can use an if statement in here, because if it's any number other than 0, it's going to trip the if statement. And any number other than 0 means something went wrong. So now we know exactly what we're doing. We're making an error message. I'll say error querying texture. Okay. And then error. And the then to end it. Okay. So now we should have a rectangle that is populated with width and height. The X and Y are still going to be 0, but the width and the height should be the width of the original image that we loaded in and the height of the original image, the texture. So if we go down here to where we're drawing it, now we can populate this with sprite rect. Did I make sure I just put sprite up here, not text? Yeah, I did put sprite rect. Okay. So let's make sure that this is working. Okay, that is the correct size, and that's what it looks like for the player sprite. So that is the other way that you can get that you could populate a rectangle. The easiest way is simply, if you already have a surface, to just use the information that's already in the surface, the width and the height information from the surface directly. That's the easiest thing to do, and it's not going to fail. The query texture can fail, so we have to check if it failed or not. But that's the two different ways that we could populate that. So now let's talk about movement. So we are down here, we are checking events, right? And these are checking key down events. So this is what's going to happen. If I start typing, let's say I type M, you're going to see one M, a pause, and then you're going to see M repeat. See that? And that's not actually typing an M every frame. That's a repeat part of the operating system of the keyboard. So it said this event happened one time, and then suddenly it's repeating that this event happened. And that's not how we want our character to move. We want our character to move if the key is in the down state. Not if a key event happened, but if the key is just actually down in however many frames you're running, and this frame is the key in the down state. So that's a little bit different. So we're not going to be using our event setup here. That's checking events to move the sprite around. We're actually going to get the state of the keyboard. So that is all for SDL query texture. So SDL get keyboard state. So what this function or word in forth is going to do is it's going to actually return us an address to an array. So this array is not something, we're not allocating space for this array. This array has already been created by SDL when we brought SDL online. And so this array already exists for us. We just need access to it. And what this array is it's an array of your keyboard. And so if you index into the array, depending on what key you're pressing, you'll know if the key is in the down state or the up state. So let's say the very first item in this array is the 0 key. Okay, so if I were to index the very first item of this array, it would tell me, is the 0 key in the down state or the up state? If it's in the down state, it's going to be a 1. And if it's in the up state, it's going to be a 0. So the way that I can index into the entire array and check any key is by using something we've already seen, which is the SDL scan codes. So these scan codes we're going to be using these to index into the array. And we've already seen these. If we look over here, this is the scan code here. Okay, although we weren't using it as an index into an array here, it's the same scan code. So it's been used multiple different ways in SDL. So these same scan codes, we're just going to use them in a slightly different way. What we're going to do is we're going to use this to get us the address to this already existing array. And then we're going to use these scan codes to index into that array and find out if the key that we care about, if it's in the down state. So this is not going to tell us if it was pressed or released. It's just going to say, is it down right now? What we need to do is we just need to hold this. So this is returning. So this is going to give us an array of uint 8s. So it's going to be indexed with a character, the character fetch. And it's going to be null as the parameter here. If we put something else other than null in there, it's going to receive the length of the returned array. But if we put null in there, it's just going to give us the pointer to the actual array. And it says returns a pointer to an array of key states. Okay, and this is internally managed. It'll also say use SDL pump event to update the state of the array. We don't actually need to do this because when we use the other function, this one that we're already using is also the same as SDL pump event. This function may implicitly call SDL pump event. So we don't need to refresh our array by doing SDL pump event. SDL pump events, we do not need to do this because this is already being done for us when we use this SDL pull event. So we actually just need the pointer to it. We don't need to do anything fancy at all. So up here, so I'm going to say null value, and I'll call this key state. So this is just going to hold a pointer. Right now it's null. And then I'm going to go down to initialize SDL at the bottom here. What I'm going to do is I'm going to use that SDL get key state. So remember, I'm going to pass in null as the parameter. So null needs to be on the stack first. And then it's SDL get keyboard state. And that's going to return us an address to that already created array. So we're not creating it, we're just getting the address to it. And so we're just going to move that address into the key state that we just made. Okay, so it's as simple as that. So we don't really need to do anything. We're just making sure that this, we can store this value. And then we're getting the actual address of that already existing array and storing it for us. So now how do we actually make use of this? Well, we already have this update text. So I'm going to create another word that is going to be update Sprite. Okay, and this is going to take nothing off the stack and leave nothing on the stack. Okay, so what we're going to do now is we're going to be checking if a key is pressed and then moving the character if it is pressed. So the first thing I'm going to do is I'm going to key state, and then we'll do SDL, and we'll do key sim scan code. So we're putting the address to the key state on the stack, and then we're offsetting it, which is actually just the first item anyway, but we're doing SDL underscore key sim and then minus scan code. So this is the scan code member. So when that's on there, what we're going to do is we're going to start duplicating this and using it over and over again. So this is on the stack, but I don't want to consume it, so I'm going to duplicate it. So I'm going SDL, and this is how I'm checking if a specific key is down. So I'm going to say left, which would be the left arrow key. So if I go SDL scan code left, now I have this address on the stack twice because I duplicated it. And if I take left, I'm going to add left to that address. And that's going to give me offset of this left address, and then I'm going to pull a character from it. That's going to tell me this is a 8-bit unsigned right here, and that's going to tell me if the left key is down or not down. So this is going to be a 0 or 1 on the stack now, depending on if this is down or not. So since I want to know if it's down, if it's 1, I'm going to compare it to 1 like this. Okay. Now I could do this and, well, I'll just show it. Yeah. We're going to add to it later, but I'll just do this one first. So if that is down, I have a longer version of the code we'll add to it. So what I want to do is I want to increment the x of the rect, not increment it, I want to decrement it. I want to move it to the left. So I'm going to put the sprite rect STL rect x. So that's getting the address of the x member of the rect. And I'm going to duplicate that because I need to get the what's held in this address, the current value from it. But then I also need to decrement that value and store it back into the address. So I need 2 copies of the address. I'm going to get the value from this, and the way I get it is this is a 32-bit signed, so I need to use SL fetch. That's a signed 32-bit fetch, and that's going to give me the number on the stack now of what is held in the X member of the rect. And now I'm going to put the sprite velocity constant. Okay, and I'm going to decrement. I'm going to use that to decrement. So I'm taking this number that was in X, and I'm subtracting sprite velocity from it. So I'm going to subtract 5 from that number. Now I've done that, I need to swap over the original address because now this number is on the stack. The address is before it. I need the address in front of it. So I'm going to swap. And I'm going to store it with an L exclamation mark, which is a 32-bit store. This works for signed and unsigned. The fetch, you need to specifically use S for signed, but the L, the storing, it works for 32-bit signed and unsigned. So I'm going to finish that with a then. And we can just check this to see if this is just working. And we do need to call this update sprite in the game loop. So right here we are checking events, and then we're updating game state. So right here I'm going to add in the sprite, update sprite. And so we should be able to check if I press the left arrow key if it moves left. And I've messed something up. So we got a stack underflow here. So let's check that out. Let me just put the rest of the code in because I'm confusing myself. I'm looking at half of a line here. I'm just going to put the rest of it in because I want to check left or A is pressed. So my notes have both of them. So I could debug this, but I'm going to eventually change it. So I'm going to say over. So I have dupe, I have SDL left plus, and this was supposed to be a fetch, not a store. So that was probably my issue right there, actually. Let me just check that real quick. Okay, so I'm going to press the left arrow key, and it's moving left. Yep. And I'm just going to do it again. I'm just holding left down, no problem. So if we wanted it to move right, I'm just going to yank that. And we'll just change this to right. And the reason why this is capitalized is it doesn't have anything to do with fourth. This is part of SDL, and it is meant to be capitalized. This one is going to be the same, still X. But we are going to be incrementing instead of decrementing. So we got right, we got left. Okay, so actually what I was talking about my notes is I actually want to check 2 things. I want to check if left or A is down, right or D is down. So let's just add that. So what I'm going to do is I'm going to use an over. So I want to get this address again. And I'm going to do the SDL scan code again, but this time I'm going to say A, and I'm going to do the exact same thing. I'm going to add it, so the offset, and then I'm doing a fetch, a character fetch from this, and comparing it to 1. And now, since we have 2 of these on there, so basically I have the answer to this with this. This is the equal is comparing them. This is comparative, so this is going to give me an answer on the stack, and this is going to give me another answer on the stack. So I have 2 answers on the stack, and I want the if to trigger if either one of the answers on the stack is true. So I can use the OR. So if either one of these, OR consumes 2 answers, and then if is going to take that answer. So if either one of these is true, it's going to be true. Okay, so I'm going to yank this right here, and I'm going to use it down here. And this one will be D instead of A. Okay, I'm just going to check if that works, and then we're going to add the other 2. So this is right, this is left, this is D, this is A. Okay, so now let's add the up and down. So just yank both of them, bring them down here. It's going to be the exact same, except instead of left, we're going to say up. And instead of A, it's going to be W. And this is going to be Y. And this one here, instead of right, this is going to be down. And this one will be S. And this again is going to be Y. And I'm just going to check the stack on the way out of here and make sure I'm not adding to it. Okay, something is wrong. I am adding to the stack. I'm going to check the stack. I'm going to comment this one out. I want to make sure that the problem is in that word right here, the update word. So what I'm going to do is I'm going to do another check here just to trace it down. That I don't want to assume that the problem is in here when it may be in here. So what I'm going to do is I'm going to disable that right there so it doesn't get called, and I'm going to check the stack here. Okay, this looks good. So the problem is coming from here. So I'm going to leave this the stack dump right there, or it's not a dump, but you know, the printing of the stack. I'm going to remove this one. And I think what's happened here is I've done the over twice, and the very last one should be a swap, not an over. So it's over swap. Yes, right down here, this very last one. See, because I keep keeping this, I'm keeping this address on the stack the whole time, so I keep duplicating it, and even the over is duplicating it. But this very last time, I actually want to consume it. So, but I do need it on top of the stack, so I'm going to swap it. So if you don't know what's happening here, I have one item on the stack. I have a 2. Let's call it A and B. A and B are on the stack, yeah? And I need it to actually be BA on the stack in the other order, but I also don't want to get rid of A. So what I do is when I say over is going to take the second item from the stack, which is going to be the A. B is on top of the stack. A is the second item down, and it's going to copy it to the top. So what I end up with is this A, B, A. So now they're in the order that I want them in. When I consume them, A is still on the stack, and I still need to use it. But the very last time, I don't want A to be on the stack anymore. I actually want to consume it. So the very last time, I'm exactly the way I was. I got A, B, but they're in the wrong order. I need B, A. So what I do is I say swap, right? And now I'm going to end up with the stack looking like this. Okay, so that just allows it to be consumed. So now our stack shouldn't be filling up like it was. and it's not right. I'm going to isolate these down again. I'm just going to let one of these run. I don't have an LSP running, and it doesn't let me automatically select for fourth to select and comment out. So I have to do it manually. Okay, so I'm just going to see if the stack is the way it's acting correctly here. And I'm going to switch this last one to a swap, because that's what the last one on the list should have been. Okay, that looks good. Okay, so I'll put the swap here, the over here. Okay, still good. Oh, I know what I did. This is what I did right here. It's this line right here. So I'm just going to undo all the way back. So it's this guy right here. It's putting the address on the stack again when I didn't need it because I copied this line up here. So this very bottom one is still swapped. That should be all fixed up now. Yep, there we go. Okay, so I have the arrow keys right, down, left, up, and I can do diagonal. And now I used if statements on each of them. So if I do opposite sides, like a left and right at the same time, I don't move. If I go up and down, I don't move. If I do A and right, it's not going to move. D and left, that's not going to move. And I can do D, W, S, A. So they all do what they need to do. And if opposites, it makes them not move. So that's movement is exactly the way I want it to move. I'm going to remove this printing of the stack. And that was down here. Okay, so that's about it. So let's walk through what we did real quick. Let me save this. And also let me set the title message right here. And we'll call this player sprite. Okay. So right here, we haven't brought any new modules in, but we did add a new constant just for the sprite velocity. We have made some new word value names, pairs, or whatever you want to call them. The sprite image, we're setting it to null. We are allocating space for a rectangle, and we do have a key state set to null. And well, let's load the texture first. So down here in load media, we are loading the player sprite, which is the G4th logo, the same way that we did before with the background image, but we are saving it in the sprite image, and we are also populating our rect with this new word, this SDL query texture. So we put the sprite address on the stack. We put two nulls on the stack because we don't care about the access or the format information. And then we put the address of the width and the address of the height for our rect on the stack. So the SDL query texture can populate those. And we're checking if this errored or not. And so since we have the texture, we are cleaning it up in our game. Where's our game cleanup? We are destroying the texture, and then we're setting that sprite image to null, so it's not holding the pointer anymore. And then we have this update. Where is it? Update sprite. So, well, let's go back up. Sorry, we have the pointer to the key state. So in initialize SDL, we are putting null on the stack because that's the parameter that we need to pass into SDL get keyboard state, and then we're returning that address, and we're storing it in key state. So when we go down to our new word, which is update sprite, we are putting the address of that on and offsetting it to the scan code. And I've duplicated that now. We're going to duplicate it many times, and the last time we're just going to swap it so it gets consumed. So this address to the scan code is on the stack, and then we are going to be checking it against the scan code left, and we get the answer to that. And we can also check it against the scan code A. We're pulling that character out and checking it against 1 because 1 means it's down. So we have the answer to both of those in the stack, and we can use this OR operator to know if either one of them were true, and then we run the if statement. If either one of them is true, we're moving the x to the left, which is a decrement. We're decrementing it by sprite velocity. And in this one, we're incrementing by sprite velocity, and we're doing the exact same thing for the y and the second two. And we're checking left, right, up, down, or A, D, A, S, W, D, in the correct order. So that's going to happen every single frame. So we're calling this in the part of our game loop where we're updating game state. Okay, so that's called update sprite. And that is it for that one. I did change the title up here. Let me double check it again, and then we'll run it one last time. Player sprite, yep. Okay, so we go up here, and that's what it looks like. We have the player sprite up there, and we can change the background color every time we press spacebar. We can move this guy around the screen. We are going faster if we move diagonally. That's because I'm not normalizing the direction movement. I'm just moving the X and the Y. So diagonally, obviously, it's almost 7.5. It's not exactly. But yeah, that's how you load a player sprite. That's how you query texture for the rectangle. That's how you move it around with the checking the key state. And that's about it. So I hope that was entertaining or educational. So thanks again for watching, and bye.